Hi, welcome back. In the previous module, we learned how to take control of the test execution lifecycle. In this module, we're going to learn about data-driven tests and how they can help us reduce the amount of test code we need to write and maintain. So in this module, we're going to start off by getting an overview of data-driven tests and how they help us reduce the amount of test code we need to write. And we'll also learn, when we're using xUnit.net, what the possible sources of test data are. We'll then head into Visual Studio and we'll write some new tests for our player character. As we're doing this, we'll notice that we're creating some duplicated test code. We'll then start to go and refactor these multiple test methods to a single data-driven test. We'll then learn how we can share the same set of test data across multiple tests or multiple test classes. And then we'll learn how we can get test data from an external source. So we'll learn how we can specify test case data in an external CSV file and then use that to drive the data-driven test. And we'll also see how we can even go and create custom data-driven attributes. These custom attributes can contain hard-coded data, or we can combine them with the external data technique so that when the attribute is applied to a test method, the test data will come from an external source. So let's kick off this module by getting a high-level overview of data-driven tests. Suppose that we're testing something, and to test it fully, we need to supply a number of different variations of input test data. So without data-driven tests, we'd have this first test case, perhaps using an input value of 0, and we'd go and write a test method, and this test can either pass or fail. We then have a number of additional test cases to make sure we're fully testing the thing. In this case, we've got 4 test cases with input values of 0, 1, 50, and 100. But notice here we've got 4 individual test methods. The test code inside these test methods is going to be almost identical, except with different values for the input test case data. If we want to add more test case data, we need to go and add additional test methods for each set of test case data. This means that we're going to end up with multiple methods when all we're doing is executing the same test code, just with different test data. Not only do we have to spend time writing all of these additional test methods, but we also have to maintain them over time. Data-driven tests can reduce the number of test methods we need to write, and also consequently the maintenance overhead over time. With data-driven tests, rather than having a number of separate test methods with duplicated code, we instead have a single test method. Rather than hard-coding values inside the test code, the input test cases are provided to the test method in a number of different ways. So here we've got our 4 test cases as before, but they're just executing the same method and passing this test case data into the method. If we want to add additional test cases, we just need to go and add a new set of test case data. We don't need to add any new methods. When it comes to providing the test method with test data, there's a number of different options that xUnit provides, including the inline attribute option, getting the data from a property, field, or method, either in the same class or a separate class, getting the data from a custom attribute that we can create, or getting the data from an external source. So this could be an external file such as a CSV, or even an external database or web service. When we use the inline attribute option to specify test case data, this data is local to a single method, so we can't share it among multiple test methods or test classes. If we want to add additional test case data, this needs to be done by the developer at the source code level. When we get our test data from a property, field, or method, we can share this set of test data across multiple test methods and multiple test methods in multiple test classes. Once again, to modify the test case data, this needs to be done by the developer at the source code level. Just as with the property, field, or method, if we create a custom attribute and supply test data via this attribute, we can share the set of test case data across multiple tests and test classes. And once again, to add test case data, we need the developer to make source code changes. With an external data source, this data is also shareable across multiple tests or test classes. But unlike these other 3 options, test case data stored externally can be edited by non-developers. This means, for example, a business analyst or QA specialist can go and add, remove, or modify test cases and the next time the test run executes, these new test cases will be executed by our test method. To demonstrate this potential explosion in the number of test methods, here we are back in our player character test class, and what we're going to do is add some new test methods. We're going to be adding some additional test cases around the take damage method here. So this first test is checking that when we take 0 damage, the health isn't reduced. We'll add a second test case, this time taking a small amount of damage, in this case 1. We'll add a third test case, this time taking a medium amount of damage. And we'll add this fourth test case to check that if we take a lot of damage, the minimum amount of health will always be 1. Let's build this. And we can see here our 4 new test cases. Let's go and run all of the tests. And all 4 of our new tests pass. But we started to get some code duplication here. We've got these 4 new test methods, but they're essentially doing the same thing, only with a different set of input data and different sets of expected results. So let's see how we can refactor these 4 test methods into a single data-driven test to reduce this code duplication. What we'll do is we'll go and add a new test method that's going to represent our data-driven test. So we'll call this test method take damage. And whereas before, for the test methods, we've used the fact attribute, to create a data-driven test, we need to instead use XUnit's theory attribute. The theory attribute tells XUnit.net that this test method should be executed multiple times, and for each execution, this test method needs to be provided with some test data. So how do we get the test data inside the test code? We do this by adding parameters to the test method. The first parameter we'll add is a parameter of type int, and we'll call this damage. So this is going to represent the amount of damage the player character is taking. We'll add a second parameter of type int, and we'll call this expected health. So we're going to use this in the assert statement to check that the expected results match the actual results. We can then make use of these parameters in our test code. So if I go and copy these 2 lines from this non-data-driven test and add it into our new data-driven test, we can now go and replace these hard-coded literal values. So the amount of damage being taken, we'll use the value passed into the damage parameter, and for the expected final health, rather than this hard-coded value, we'll use the value that was passed into the expected health parameter. So now we've got these parameters in our test method, we need to tell XUnit.net where these values are going to come from. The simplest way is to use inline data. To use inline data, we add an attribute called inline data. Once again, this is an XUnit.net attribute that's going to allow us to pass test data into a data-driven test. If we have a look at the arguments to this attribute, notice we've got this params object array. This means we can specify an arbitrary number of values, specifying individual elements of test case data. So for our first set of test case data, we want to mimic this take 0 damage test. So we want to take 0 damage and expect 100 health. To do this, we specify the values as part of the inline data attribute. Now when the test method executes, the values from the inline data attribute will be passed in a positional way to the parameters of the test method. So the first value in the inline data attribute will be passed to the first parameter, and the second to the second parameter. Let's go and build this, and we'll head to Test Explorer. And if I scroll down to our player character should tests, notice we've got this additional test now called take damage. Also notice that we've got in parentheses the values that will be executed for this test method. It's telling us that when we execute this test, we're going to get the damage parameter set to 0 and the expected health parameter set to 100. We can right-click and run this just as we would run any other test, and we can see the test passes. If we want to add additional test cases, we don't have to modify the code now, we just have to add additional inline data attributes. So let's go and add the test case to mimic this take small damage test. So what I'm going to do is duplicate this line. We'll change the damage to 1 and the expected health to 99. Let's go and add this take medium damage version. We'll set the damage to 50 and the expected health to 50. Finally, we'll go and mimic this have minimum 1 health test. This time taking 101 damage and expecting 1 health. We'll build this, and if we have a look in Test Explorer now, we can see that we've got an additional 3 test cases, and in each test case is showing the values that will be passed to the test method parameters. Let's just go and run all of these tests, and all of the tests pass. Now that we've replaced the 4 original test case methods with a single test method, we can go and remove all of this test code. So let's just go and delete that. We now only have a single test method to maintain for all of these take damage test cases. We'll just build this to make sure there's no errors, and we'll go and run all of our tests again, and all of our tests pass.